Okay, number 7, a 20-foot ladder leans against a house, making a 75-degree angle at the ground. So that's where that 75-degree goes. How far above the ground is the top of the ladder? So that's what we're trying to find, is the height. All right, set up your trig, and we got ourselves a sine of 75 degrees is opposite over hypotenuse. Go to your calculator, type it in, and we do get 19.3. A child flies a kite when the angle of elevation of the kite is 28 degrees. The kite is 200 feet above the ground. At this instance, how many feet of string are running from the child's hand to the kite? Okay, based off that picture, we have ourselves another sine. This one is going in as division, everybody. So 200 divided by the sine of 28. And I do get the 426. Number 9, a boy leans out a window 40 feet above the ground and heaves a water balloon out the window with an angle of elevation of 32 degrees. He is aiming for a poor unsuspecting little girl who stands on the ground 20 feet away. Does the balloon hit the girl? So what we have here is, what if, based off of where the boy is at and the angle of elevation he throws it at, does he throw it at that girl, or does it land in front of the girl, or is it behind the girl, or is it exactly 20 feet? So what we're doing here is seeing if we put this as x, does that 40, does that 32 degrees turn out to be the same 20 as our x does? So I get a tangent of 32 equals opposite over adjacent. So when I go and type this into my calculator, I'm looking for 20. 40 divided by the tangent of 32, way off. It's at 64 feet. So this kid is way off, hits it at 64 feet, way over here. So no, he does not. He's off by 44 feet. Number 10, the angle of depression from the airplane to the control tower is 49 degrees. So we get ourselves an airplane. Okay. The angle of depression from the airplane, and then we're going to put our control tower. Put that right here. Okay. Depression is off a horizontal, and we are, I don't know why I put those as dots. Do this. Okay. So angle of depression is off a horizontal, looking down, and the airplane is flying at 5,000 feet. So we know the airplane is 5,000 feet in the air. The line of sight distance, so that is the hypotenuse. And I always bring in that depression to an angle of elevation, just because then it makes it for a quick, not quick, but it's just a different viewpoint, I guess. But I want to find that. So we have a sine of 49 is 5,000 over the hypotenuse. So the line of sight distance is 5,000 divided by the sine of 49, which turns out to be 6,625 feet. Now, if it wants the horizontal ground distance, that's going to be the y. And I will use tangent, it looks like. Tangent of 49 is opposite over adjacent. So 5,000 divided by the tangent of 49. The horizontal ground distance is 4,346. 4,346.4 feet. 4,300, and I think that's a typo. 49, 5,000. Looks like I typed in right, so I think this is a typo right here. 4,346.4 feet. Number 11, suppose your angle of elevation to the top of a water tower is 78 degrees. How far are you standing back? So assuming that water tower is at a right angle, looking at the top of it, the water tower is 145 feet tall. How far are you standing back from it? So we have a tangent of 78 equals 145 over x. So divide it. 145 divided by the tangent of 78. 30.8 is correct. On these, all right, here it's a rise over right now, it's a negative slope. So down 2 and right 1. So I got that angle going. So we have another tangent, but it's that type of line because it's a negative slope. So second tangent of 2 over 1, which turns out to be, 63 degrees. The other one is the same idea. It's a negative 5 force. So there's my x, and it's another tangent of 5 force. The second tangent of 5 force. Yep, and there's my 51 degrees. All right, excuse me. The area of a rectangle is 168 feet. What are the measures of the acute angles formed by the diagonal and the sides of the rectangle? Well, it's a rectangle. We know that's a right angle. We know the length is 7. 168 divided by 7 tells me this has to be 24 feet right here because the area was given as 168. So 168 is 7 divided by the width, 7 times the width. That's where I'm getting that 24. Now after that, I want to find those two measures. So I'm just going to use tangents. For x, I'm going to stand at x there and say tangent x is 7 over 24. And for the other one, I go stand at y and say 24 over 7. I do the inverses on both of those, and they both should turn out to be complementary. Yep, 16 there and 74 on the other. What is the area in square meters? Okay, area of a triangle is 1/2 base times height. Okay, well, we have ourselves some 45s hiding in here. If that's 45, that's 45. If that's 19.5, this is 19.5. That's 19.5. And I'm done. Area of a triangle is 1/2 base times height. The base and height have to be perpendicular. I found the base to be 19.5 doubled times the height, which is perpendicular to that. So 0.5 times 39 times 19.5 does turn out to be 380.25 meters squared. If I want to evaluate the cotangent of 42, I can only do that in my calculator as 1 over the tangent of 42. 1 divided by the tangent of 42. That is where I'm getting that 1.111. And if I want to do the exact same thing for secant, I got to do cosine. So 1 over cosine of 35.5, 1.228, which confirms it out. All right, that is our quiz.